We're on our way to the Knoxville area. Today we're going to be looking at how we actually put our geologic maps together. We will be going to the office to look at the procedure in office. We're also going to be going into the field to be looking at some of the outcrops that we're working with to see just exactly what the technique is in the field.
John Q. Public might have difficulty kind of deciphering what's going on here.
Yeah, I'm
right?
thinking.
So one thing we
June Q Public is having trouble deciphering right now.
This is very important for all land use purposes.
Okay.
It's a topographic quadrangle map, and there are
Right.
804 of these that cover the entire state.
Okay.
Any land use development in some way should start by considering what the bedrock geology or the superficial geology deposits are like at that site.
Right.
One thing we can do, and we have done, is create a derivative map, and for say
That sounds like something I had in calculus.
well, it's kind of dumbing down this
Yeah.
information
Now you're talking.
to where we can highlight areas that may be prone to forming sinkholes. So we could make a map that's just showing, that particular geologic hazard. This is primarily, it does involve field work.
Right.
Just walking the ground.
Right.
But we do incorporate subsurface data when we have it available. Well, right now we are just a little bit off of the map area that I'm working on this year, and we're heading towards the Tennessee River and towards a road that cut through the side of the ridge there near the river, where there was a natural cut where they did expose the bedrock for us to see. On the map this afternoon or this morning, we were pointing to the geologic contacts, or we were pointing to the different colored rock bands.
Right.
Right, do you see how all the colors are all aligned northeast, southwest like that? But the ridge and valley structure, right, has that northeast, southwest grain all up and down East Tennessee. And that is actually controlled, the topography is actually controlled by the bedrock layers. And, bounding those different colors are the geologic contacts between the different rock units.
Got you. Okay.
Right? And so, these tilted rock layers, when they intersect the surface, the contact between those layers is exposed at the surface. All right. And again, we usually are defining our individual formations based upon distinctive characteristics of those rocks that make them easy to identify. The differences with respect to their weathering characteristics. Some weather much easier than others. So the ones that don't weather well, they create the ridges. The limestones and shales that weather more rapidly, they tend to create the valley areas. And because this doesn't weather much at all, all this dolostone, again, will dissolve over thousands, millions of years, and this will survive. And we're going to be walking this ridge in this area, and this is what we'll start to see in the soil. Chunks of this chert that has this stromatolitic structure. And it says, okay, I know I'm in that position in the Knox group.
Ooh, that's gonna look like feel like a possum.
But as the dolomite dissolved away,
Right.
that weathering
That's what you
resistant
get.
chert just leaves that in the soil. And
Right.
so we can track the characteristic chert intervals into the woods and
Gotcha.
confidently say, yeah, I think I'm above this particular bedrock unit.
Right.
So how many feet in a mile?
What is it, like 3,670 or something?
5,280.
That's what I just was thinking.
Okay.
Yeah.
That's what I meant to say.
I was just testing to see if you knew.
Well, I know the Boy Scouts usually know that. That's something
Yeah.
for some reason they have to memorize.
Yeah, I
but,
somehow didn't make it into that group. I don't know
You're
what
talking about
happened.
kilometers.
Yeah.
Nice big piece. Okay. And now I'm getting a little bit more of a
Get
true
a fresh look at it
yeah,
in there.
compared to that, right?
Right.
And we describe characteristics about it. We know it's not going to fizz like
Right.
this. If this were limestone, it would fizz by putting the acid on it directly.
Hydrogen peroxide, sort of? Kind of that same kind of bubbling that much?
Yeah.
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 Okay.
Yeah, that's a good. That's
So you
a
would
good-
know it?
Yeah.
You would definitely
Definitely
know
no. Creating more surface area. So you take out your hammer or your rock knife. I mean your knife, some metal knife. I mean a little pile of powder. Put some acid on it. Because it bubbled by making the powder, I know that's a dolostone.
I mean, it is. It's awesome. Really, it's cool. And just the amount that you can learn about what went on millions or billions of years ago from looking at, what most of us would say, a little rock,
Right.
It's just
It's
a
cool.
snapshot. We're trying
Right.
to look at the whole story from this
Right.
snapshot.
It's amazing.